When you look at a globe, the vast blue stretches of the Pacific and Atlantic feel permanent, like the eternal foundations of our world. But beneath the crust, a relentless geological engine is running. Tectonic plates violently tear open new basins and slam others shut over millions of years. Each ocean basin represents a temporary geological window, a cycle of birth, expansion, and eventual closure. Long before today's familiar continents ever formed, massive boiling seas with alien chemistry dominated the young globe before vaporizing entirely. Understanding the origin of complex life requires looking past today's map and into the extreme, vanished waters that forged Earth's biological operating system. 4 billion years ago, the Archean Ocean was a simmering, highly acidic bath, oxygen-free and tinted pale green by dissolved iron. With a lethal surface, the first whispers of biology took refuge in the crushing darkness of the abyssal floor, fueling themselves with geothermal energy. Eventually, cyanobacteria floating toward the shallows figured out how to capture sunlight and split water molecules, releasing free oxygen. That oxygen reacted instantly with dissolved iron, triggering a chemical cascade causing the global ocean to rust. For hundreds of millions of years, these rust particles rained down, clearing the water and burying iron in thick layers on the seafloor. We find the proof today in these alternating bands of red and gray rock, the physical record of a planetary scale chemical shift. These microbes actively engineered the planet by locking away the iron, clearing the water, and allowing oxygen levels to finally climb. That progress stalled during the cryogenian period. Global temperatures fell sharply, causing miles of solid ice to expand from the poles, sealing the oceans. Trapped in total darkness, the water lost its oxygen and saturated with toxic hydrogen sulfide. But the ice provided a mechanical advantage. Glaciers acted like planetary grinders, scraping continental rock and dumping massive amounts of phosphorus into the sealed water. When greenhouse gases forced warming, the ice cap shattered. Nutrient-rich deep water cycled violently toward the sunlit surface. This nutrient surge fed a global bloom of algae, triggering a second rise in oxygen and creating the high-energy environment required for complex animals. As continents shifted and sea levels rose, warm, shallow oceans flooded directly across the landmasses. These temporary shallows incubated alien ecosystems. During the Ordovician, 7-foot sea scorpions hunted above dense carpets of stationary filter feeders. In the late Cretaceous, the Western Interior Seaway flooded North America, dividing the continent into 2 separate islands. Mosasaurs ruled this shallow incubator. These marine lizards had immense jaws, an extra row of teeth on their palates, and flippers adapted for ambush. Because these seas were geographically trapped and temporary, they acted as intense pressure cookers, forcing life to specialize rapidly before the waters vanished. Eventually, tectonic collisions uplifted the ocean floor, draining the basin to form the Rocky Mountains. The golden prairie grass of the American Midwest now covers the exact physical space where mosasaurs once patrolled. The ocean floor was simply traded for the plains. That Archean rusting event created the immense iron ore deposits we mine today. This red earth provides the raw materials for the steel in our infrastructure and our modern cities. While the Atlantic and the Pacific will eventually close, the legacy of these vanished seas is permanent, encoded in the iron of our world and the DNA of our bodies.